Welcome back to our series on non-interpretive skills. My name is Nadia Kedem and my guest today is Lyle Sa. Lyle, did you want to introduce yourself?
Hi, everyone. My name is Lyle Sa. I'm a fourth-year medical student at UMass, working with Dr. Kadam on QI projects, and this is an exciting project, creating a podcast. So hopefully it's helpful.
Thank you, Lyle. So today we're going to talk about human factors and just culture. I hope we can get through all of it. There's a lot of content here in the ABR NIS syllabus. So what do you know about human factors and human factors engineering?
So human factors is a concept that I encountered when interacting with nurses. In line with to err is human, we have inherent qualities as humans that leave us vulnerable to making errors, whether it's not being able to look at everything, identify everything, or things that just don't occur within our vicinity. Human factors engineering is a whole discipline that tries to identify and address problems that we as humans have. It takes into consideration our strengths, but also our limitations. The equipment we use, a great example is IV lines that can't be connected to specific machines, things that have been designed to factor in our error prone nature. That's very broad, but
Yeah,
that's how.
that's perfect. That's perfect. Yeah, usually the work product is the interaction of the human and the environment, the tools that they have, the skills that they have, the policies that are in place. So all of these factors interplay, and there can be failure in any of these, but humans definitely are prone to error, like you said. So there could be issues with that. The prime example I think of for human factors engineering is when have you ever seen a car drive off from the gas station and they still had the nozzle in the tank?
Yes. 100.
Yeah. So that happens to people because we are tired. We just gas up the car. You forget it's still in there. You've paid. You get in the car. All you want to do is go home, eat dinner, relax, and then you forget. In the past, this was a big issue because when you drive off and you rip off that pipe, then actually gasoline can leak at the gas station. And that's a huge safety hazard. So in the past, they had to shut down the gas station and secure the area. It was horrible. So now human factors engineers have come to realize that this happens all the time, everywhere. So we should have a solution for that. We should anticipate that this will happen because there are humans driving the car. And so they built a little valve. And now when you drive off, it disconnects at that predefined level and it closes off the pipe. So there is no gas leak. Also at the gas station, the nozzle for diesel versus gasoline are different. You can't get diesel into your gas engine because the nozzle just won't fit in the tank. The example they have here for healthcare, there are two examples. One of them is an elderly man who has a cardiac arrest while in the hospital. And when the Code Blue team arrives, they are unable to shock him because the defibrillator pads cannot be connected to the defibrillator itself. How can something like that happen?
I think they were intentionally designed if the design companies are different or if the voltages are different, things that have either been intentionally or unintentionally placed in. But
Yeah. I think this happens when on the same unit you have defibrillators from different manufacturers. So the cables don't fit on the other manufacturer's device. They should all be standardized so that it always fits.
yeah.
And there's also other examples of medications and lines to oxygen tanks versus nitrogen, where the connecting cable only fits on one of the tanks, which is the appropriate one. That's an example of human factors engineering. Just make it impossible to do the wrong thing,
Yep.
enable people only to do the right thing. So that is human factors engineering. Great. We talked about standardization being important. They also talked about checklists. Do you know an example of a checklist in healthcare?
I can think of maybe an OR setting. I have a lot of exposure to that where they do a timeout, which has a mental checklist. Some ORs have like a visual checklist of They need to identify the patient and it needs to match with the bracelet. There are things that are standardized, at least within that institution, to make
Mhm.
sure that all of the check boxes are checked before they actually start the procedure.
Yeah, that's a good example. So make sure you have the right patient for the right procedure and you actually mark the site of the procedure. Because since you bring up surgery, it's happened sometimes that they amputated the wrong leg or something like that. It's like really terrible. Okay, so that checklist for radiology, an example of a checklist also is the MRI screening form. So we have a huge checklist of things that we need to ask each patient before an MRI to make sure it's safe for them to go in there. And there's also something called standard work. Have you heard of that before?
I don't think I have.
Okay. So standard work is basically where a group of people agrees on what is the best way to do something. And then they actually write it down and make sure that everybody in the group does it that way. So it's not necessarily something that's nationally the best way of doing things. It could be local practice, but that's how things are done. For example, one standard work for us is when the MRI technologist is done scanning the patient, they have to go into the PACS system and make sure that all the images have arrived in PACS.
Oh.
Because sometimes there could be a technical issue and the images are not all sent over. And it's really annoying for the radiologist to open a number of studies to read them. And then halfway into the reading, you figure out that there's something missing. So you have to stop, you have to call somebody to send it and all of that. So to avoid those kind of delays, that's a standard work that we have. Okay, great. So those are three ways for standardizing, like using compatible equipment, checklists, and standard work. There's also something to be said about effective communication. They talk about conveyance and convergence of communication. What are those two things?
When we're communicating with someone, you're trying to give information. The transmission of the information itself from one party to another is conveyance, conveying the information. And the second part of that communication right here is convergence. Both parties need to understand mutually what is being discussed. And if there's any clarifications that need to be made, it's made. So convergence of the shared meaning or the shared information.
And then in the medical field, we talk about read back, like you're communicating something and you want the person to say it back to you so you can make
Yes.
sure that they understood it. Perfect. Okay. All right. There is this concept of a high reliability organization as an example of a really safe kind of environment. There are a few things that we can learn from such organizations. Do you have any examples of an industry that's considered high reliability organization? And it's not healthcare because we kill a lot of people. So we are not actually a high reliability organization. Can you think of something?
This might be wrong, but finances, like the stock.
No, no.
Okay.
I wish, not finance. So one example is a nuclear plant. Nuclear plants need to be highly safe, or otherwise we wouldn't be able to trust them to generate energy. When there is a nuclear plant disaster, it's really a disaster. The other example that's often used is airline carriers. Like the military uses these ships from which you can start and land an aircraft on the ocean. So they also have to be highly reliable because otherwise our pilots would die just taking off
Oh,
and landing. So
poor.
they have the specific features that characterize a high reliability organization. One of them I can tell you is that their singular focus is on being safe versus in healthcare. What is our focus in healthcare really?
Delivering patient care, patient outcome.
Yeah, but shouldn't it also be being safe? Shouldn't that be our number one concern?
It should be do no harm.
Yeah, yeah, it should be. It should be. But there is competing interests. For example, we can't provide any healthcare if you don't make enough money to pay for the physicians and nurses and equipment in your facility. So there is always at least that competing interest of being financially viable. And then in an academic setting, there are so many other competing interests like education, research. So there is unfortunately not a singular focus on safety, although it should be. But that's it. For high reliability organization, there are some features that we look into that we can learn from. There is the idea of anticipating error and then containing error. With anticipating error, there are three kind of buzz terms. It's preoccupation with failure, reluctance to simplify, and sensitivity to operations. What is your understanding of preoccupation with failure?
So I think it's relatively straightforward. This one of the other two may be difficult, but
Okay.
when we're actively watching for these signs or clues, as they put it, that indicate something going wrong, we're better able to quickly detect that error or issue and then hopefully respond to it in a timely fashion.
Yeah. It's actually amazing how the difference in the mindset here makes a big difference. So, the mindset in a high reliability organization is that errors will happen. They
Mhm.
already know we're going to have errors. And there is the desire to catch the error, hopefully before it even happens. Like any unsafe condition, empower your people to report it and find solutions. And so when the error actually happens, these systems are not surprised and they spring into action right away. Okay, here we got an error. We got to fix it. They go into investigating and fixing. In healthcare, unfortunately, the attitude is different. We have an expectations of not making any errors. So when an error happens, we're stunned that there was an error. And there is all this huge effort to get past this moment of stunning and shock and getting into fixing mode. So what can we learn? How do we investigate this? And let's fix the system. There's this huge emotional component that's hard to get past sometimes, and that HROs don't have it because they already anticipate that errors can happen and they're constantly working on trying to prevent that.
Yep.
The reluctance to simplify means when you have an error, you're not taking the first explanation for it, but you really want to dig deep and fully understand the entire system that caused that error. And errors are usually multifactorial, it's not one thing, but there's usually something else already wrong that sets up this error. So they really want to investigate it and fully understand it and not take the first available explanation. And this sensitivity to operations, I agree, it's a little bit abstract, that term, but it means that they realize that what's actually happening in the workplace is different from what's supposed to happen. So in healthcare, again, when we onboard somebody, we say you should be proofreading your reports so that there aren't any errors in it. But the reality is that we're so busy that we usually omit that proofreading. And so we do have typos in our reports. This should be just an expectation that humans will make these kinds of mistakes. You recognize that this is something that will happen and find ways to improve it in other ways. So that is sensitivity to operations. So real life is different from what it should be in theory.
Yep.
A very different mindset to what we have. And so once an error has happened, these HROs or high reliability organizations have commitment to resilience and deference to expertise. Do you have any idea what those two mean?
So when we're trying to contain these error or address them, number one, commitment to resilience is this one is to assume that unexpected trouble is both ubiquitous and unpredictable, and they recognize this, fully anticipate these events. So they empower individuals to adjust and innovate as necessary. So there's this inherent commitment to keep adjusting, keep improving, keep trying to find better solutions, better ways to not only identify it, but learn from them. So it's the cyclical, continuous process or commitment to
Yeah. Yeah.
um, addressing it.
So there are two levels of resilience. It's at the personal level. So when I made a mistake and I feel terrible about it, how do I develop resilience and move forward so I can go into analyzing this error and help solving the error or make myself prevent this error from happening again. And there's resilience at the organizational level, how
Mm.
you absorb an error that happens that can harm an organization significantly. If somebody died because of an error, you may have to pay millions of dollars of damages. And that's a big blow, but you have to recover from that and move on quickly and investigate and just make your systems tighter and safer based on what you learned from the event. So that's where there's commitment to resilience. So it's we will get better and we'll be safer as a result of any errors that might happen.
Right.
And then the deference to expertise just means so we have people that are supervisors, so maybe my division director or my department chair, and they have more authority because of that position. But do they really know why the images from the MRI scanner didn't show up in PACS? That is really either an IT person or the technologist who knows what happened. So the expertise doesn't necessarily lie with the person of authority. High reliability organizations recognize that. And when they investigate errors, they bring the frontline people into the team who have the knowledge of what happened and not the people who are in a position of authority. So that's very important.